Hello friends, in this class we will study double points. First of all, singular points. A point on the curve at which the curve behaves in an extraordinary manner is called a singular point. There are two types of singular points, points of inflection and multiple points. So multiple points. A point on the curve through which more than one branches of the curve pass is called multiple point. Then what is a double point? A point on the curve through which two branches of the curve pass is called a double point. Now this classification of double points. Node. A node is a point on the curve through which two real branches of a curve pass and two tangents at which are real and distinct. So just see this picture here, diagrammed here, x-axis, y-axis, and here this curve is still going like this and then this. Okay, so at this point, if we see the tangents to this branch as well as this branch of the curve, these are different, and okay, and these are real. So therefore this is a double point. Now cusp, sorry, this is a node. Then cusp, a double point on the curve through which two real branches of the curve pass and the tangents at which are real and coincident. So you can see, just think of graph like this, curve like this, and at this point you can see this the tangent to this part and to this part on this point to this curve is same, and these are real and distinct branches of the curve also. So this is known as conjugate, sorry, cusp. And now coming to conjugate point. Sorry, a point on the curve in the neighborhood of which there are no other real points on the curve is known as this isolated or conjugate point. It is just, we can imagine just like this. Okay, this point may be, conjugate point. At this point the tangents may exist and but imaginary. Okay, and two tangents at conjugate point are generally imaginary, but sometimes they may be real. Conjugate point is also known as isolated point. Now procedure to find the position and nature of all points. The steps. Find this partial derivative of this equation of the curve. Okay, that is noted by fxy. Okay, then find out the partial derivative of with respect to x, with respect to y, and then double partial derivative with respect to x, with respect to y, and then fxy. Okay, solve fx equal to 0 and fy equal to 0 to get possible double points. Reject those points which do not satisfy the equation of the curve. Okay, remaining points are double points. Number 3, at each double point find d. Okay, this is not discriminant, just a symbol d. fxy whole square minus fxx fyy. If this d is greater than 0, the double point is a node or conjugate point. If d is equal to 0, the double point is a cusp or conjugate point. Okay, in cases of A and B, find the nature of double points by shifting the origin to the double points and then testing the nature of tangents and existence of the curve in the neighborhood of new origin. And lastly, point C is if D is less than 0, then the double point is a conjugate point. This is the procedure. And now coming to examples. So find the nature of double points on the curve. So this is the equation, given equation of the curve. Okay, if we just find the fx, it will be 2x minus 4, and fy, again just differentiating this with respect to y, keeping x constant. So you do this calculation and you reach at minus 3y square plus 4y plus minus 1. And putting fx equal to 0, it gives me x is equal to 2 from here, and then doing fy equal to 0, just solving this quadratic, we get 3 and 1, values as 3 as 1. So therefore 2 comma 3 and 2 comma 1 are the possible double points, but 2 3 does not satisfy the given equation of the curve, so therefore it's not a double point. So therefore 2 comma 1 is the only double point of the curve. Now what we do after this, shift the origin to this double point by doing this transformation, x is equal to capital X plus 2 and y equal to capital Y plus 1. The equation, therefore the equation 1 becomes like this, and just putting these values and solving, we get x square minus y cube and minus y equal to 0. Now equating to 0 the lowest degree term in this equation now, that is x square minus y square for getting the equation of tangents. So when we do it, we get y equal to plus minus square root x. So for all the values of x, I think so. This gives me, two real and distinct tangents. So therefore, the real branches of the curve exist in the neighborhood of point 2, 1, and hence it is a node. It is a node. So only the value of d, whether it is greater than 0 or equal to 0, that is not sufficient to determine the nature of double points, because sometimes they may that can lead to wrong results. So this is better thing, that shift the origin to the double point and then test the nature of tangents as well as the existence of the curve in the neighborhood of that point. Now coming to question number 2, position and nature of double points on the curve this. Okay, the equation of the given curve is, I have written it just like taking right hand side to left hand side and just by this fxy equal to this equal to 0, and again doing fx equal to 0, fy equal to 0. So this is fx, this is fy. For double points we solve these, and after solving this we get x cube equal to 0 and this, so x is equal to 0 and x is equal to plus minus a, and y is 0 already. So therefore these are the possible double points, but these points do not satisfy this equation, and 0 0 is the only double point that satisfies. So what we do after that, okay, we can do this fx x fy y also fx y. At this point we can see this value is 0, so indicating that the point will be a cusp. But whether we are sure about it, yes. So if we just shift the origin to the double point, that is 0 0, that is the same thing, okay, that is the origin only, so there is no need of doing all that. So just going to this equation here, uh, just finding the value of y, and we get this. So for very small values of x, positive or negative, this here, because a is positive, and we have very small values of x, okay, so in comparison to minus 3a square, this term would be very small. So the square root will be a square root of minus quantity, that is okay, negative quantity, at which will be imaginary. So hence this y is imaginary, and no portion of the curve lies in the neighborhood of origin, and hence this point 0 0 is the conjugate point, although this method was indicating that it is a cusp. So thus we should not rely on this method more, but yeah, it gives us a simple indication that okay, whether it will be a node or it will be a cusp or conjugate point. In case this quantity is negative, that is direct indication that the double point is a conjugate point. Now coming to the next, that is find the position and nature of double points on this curve. So A is given greater than 0. By equating to 0 the lowest degree terms, the equation of tangents to this curve are given by this. and it indicates that no, the origin may be a cusp or conjugate point because the coincident tangents y equal to 0, y equal to 0. But from equation 1, if we see from here, taking y to left side and other things right side, so this is the relation to y and x. So if we see this now, you can see here again this term 3a square will be higher than this term, okay, for very small values of x, whether positive or negative. So therefore the y will be imaginary at this origin, okay. Therefore origin is a conjugate point. Another form of asking this question would be show that the origin is a conjugate point on this curve, okay. Same thing. Now coming to next question. Discuss the position and nature of double points. This, so here fx is this. Just taking right hand side to left hand side, and now this, just expanding all this, we get f is equal to this, fx equal to 0 gives me this, and if I solve it I get this quadratic in x, and we're solving this. After some calculations we reach at this point, and we get this value of x are, values of x are a and this one. Similarly, if we do fy equal to 0, I get y equal to 0. This possible double points are a comma 0 and this comma 0, but a comma 0 satisfies the given equation of the curve only. This point does not satisfy, so this is the only double point. And now shifting the origin to this double point a comma 0. So doing this transformation, we have y square is equal to this, and y square is equal to x square into x plus a minus v, and just doing this we get 0. Now this is the equation of the curve, new equation of the curve, and equating to 0 the lowest degree terms. Now what is the lowest degree term? This is the lowest degree term, y square minus x square into a minus v. So y square is equal to this, so this gives me plus minus x square root of a minus b. Now this nature of y depends only on a and b. If a is greater than 0, if a is less than, sorry, a is greater than b, a is less than b, and a is equal to b. So there will be three cases. So three cases arise when a is greater than b, y is real, and two tangents are distinct. So therefore origin is a node. When a is equal to b, what do you get? A minus b 0, so it is plus minus 0 means two coincident tangents. Origin is a cusp, and when a is less than b, this is imaginary, and hence this will be a conjugate point. So I hope you have now understood the concept of double points, and I have given you enough number of questions, and you try out them yourselves. Okay, thank you.